Hi, Assalamualaikum. My name is Yasmina Ustina binti Fazladin. My metric number is J2280228. Today, I would like to present about thermogravimetric analysis (TGA). I will share a little bit about the machine, including what is the thermogravimetric analysis, the process to operate the machine, and also its advantage and disadvantage of the TGA machine. Thermogravimetric analysis (TGA) is a method of thermal analysis in which the mass of sample is measured over time as the temperature changes. This technique is used to determine a material thermal stability and its composition by monitoring weight changes associated with decomposition, oxidation, or loss of volatile substance. For the process of TGA, we use candle wax as our sample. First, we weigh a sample until 14.7999 mg using analytical balance before put it into alumina crucible. After that, we record the weight. Then, we put one empty crucible alumina and one crucible alumina that contained our sample into the machine TGA to get the result. Lastly, after got the result, we use Ftir software to analyze the data. Next, there is some advantage of thermogravimetric analysis machine, which is high sensitivity, wide temperature range, controlled atmosphere, versatility, and also cost effective. However, there are also some disadvantages of TGA. Among them, limited information, sensitivity to experiment conditions, limited to thermal events, time consuming, and the last one is sample size limitation. So that's all from me, and I will pass it to Faizal. Thank you.
Now I would like to explain about analysis data. Number one is temperature. TGA measure the samples which change as a function of temperature. The temperature range and heating rate are controlled parameters during the analysis. Number two is weight change. Weight change is the primary data recorded is the percentage weight change of the sample over the temperature range. Number three is inflection point and peaks. TGA curve often show inflection points or peaks that indicate specific events such as volatilization, decomposition, or oxidation of the sample. Number four is mass loss steps. TGA data typically identify distinct step or stage of mass loss. Each step corresponding to different processes occurring within the sample such as evaporation of volatile component, decomposition of organic matter or oxidation reaction. Next, thermal stability and kinetics. TGA data can be analyzed to assess the thermal stability of material by examining onset temperature of decomposition, activation, energies, and reaction kinetics. Last is comparative analysis. TGA data is often compared between different sample formulation or condition to evaluate difference in the thermal stability, decomposition, pathway, and material composition. Thank you. For now, Application. Only certain material can be used in TGA machine, which is ceramic, polymer and plastic. Only sample in solid form are allowed. If in liquid form, only some other machine can be allowed. The type of gas can use oxygen, nitrogen and normal air. For application is number one is material characterization, determining the composition of complete materials by measuring weak loss at different temperature, such as in polymer blends, pharmaceuticals and food product. Number two is quality control, monitoring batch to batch consistency in manufacturing process to maintain product quality. Number three is research and development, studying past transition in materials such as melting, crystallization, and glass transition temperature. Thank you. Now, conclusion. Thermogravimetric analysis (TGA) is a crucial analytical technique used in various fields to study materials, thermal properties, providing insight into composition stability and decomposition processes. It aids in quality control, product development, and sustainable practice, supporting innovation and environmental stewardship. Thank you.
Assalamualaikum, my name is Nurul Fazala Metirosdi. My metric number is J22A0136. Today I would like to present about FTIR. FTIR is Fourier-Transform infrared spectroscopy. Is a technique used to identify material by analyze the infrared light by the absorb. Different molecules absorb infrared light at different frequency, creating a unique fingerprint. By comparing this fingerprint to a database of unknown material, scientists can determine the identity of an unknown sample. FTIR is used in many fields like organic chemistry, polymer science, and forensic.
Okay, move to the sampling process for FTIR. Start with sample preparation. If the sample is in the form solid, we grind into a fine powder. Then we mix with potassium bromide. Then we press into pellet, and we directly place on ATR crystal. If the sample in liquid form, we dissolve in solvent. Then we place drop on ATR crystal. Then we place between IR transparent windows. Then we set up the FTIR spectrometer. Next, we turn on and warm up the spectrum and align and calibrate interferometer and IR source. Then we collect background spectrum. Then we place prepared sample on holder or ATR crystal. Then we collect sample spectrum. Then the data will processing and accept background spectrum. Then we apply Fourier-Transform. Next, we obtain final absorption spectrum. Then we analyze spectrum and identify absorption peaks, and we compare with reference spectra. Then we interpret functional group and chemical composition. Then it's with documentation. Then last but not least, record experimental conditions, and we save spectra for analysis data.
Lepas tu, bila benda ni, kalau dia kena pin. Okay. Bila pin, kita akan tukarkan desikan dia. Dia kata change desikan dengan pin. Okay. Change desikan dia ada kat sini. Okay. Ni gambar desikan dia adalah dalam ni. Dan kita biasanya akan tukarkan desikan ni tiap kali bila benda ni bertukar pin. Kita akan tukar dalam 2 hari ke 3 hari, macam tukarkan kepada cuaca lah. Okay. Bila dalam cuaca lemah, benda ni bertukar pin. Okay. Bila kita tukar, kita akan pulse dalam 10 ke 15 minit. Barulah alat ni ready untuk kita test sampel awak. Okay. Ni stage untuk letak sampel awak, di mana saiz dia hanya 3 mm. Mana sampel awak tu kena besar daripada 3 mm, cover lah crystal. Dia panggil APR. Jika sampel tu liquid, kita tak guna dia punya penekan ni, pressure ni. Kalau powder dan solid kan, kau tak sampel kan, kita demo macam ni lah. Okay. First kita akan cuci dia dulu dengan etanol. Kenapa etanol? Sebab etanol ni mudah serap, jadi kita tak tinggalkan apa-apa kesan bila korang baca dia. Sebelum kita push ni dekat, dia nak buang segala moisture yang ada dalam ni. Dekat yang stage ni, dia akan buangkan segala moisture. Okay.
Kita kena pastikan kosong atas stage tu, tak nak ada apa-apa. Okay. Ini spektrum water, yang ni carbon dioxide. Dia keluar siap-siap. Okay, bila kita scan ni, dia akan tolak. Dia akan tolak water vapor dengan carbon dioxide spektrum tu. Yang ni yang sampel punya lah. Kita siap dah ni kiranya. Sekejap je, dia dia simple. Yang part nak analisis tu yang susah. Bila kita dah siap ni, kita cuci biasa. Kalau powder kita cuci lah. Kalau liquid pun, kalau solid, kalau tak tinggalkan kesan apa-apa, it's okay lah.
The next slide is advantage and disadvantage. Advantage of FTIR have a 5. First, simple mechanical design, elimination of streamline and emission contribution. Third, powerful data station. Next, measure of molecule in the universe absorb mean infrared light, making it a highly useful tool. Last one is universal technique. For the disadvantage of FTIR is cannot detect atom and monoatomic ion single atom and contain to the chemical bond. Second, cannot detect molecule composed of two identical atoms similar such as N2 or O2. Third, aqueous solution are very difficult to analyze water in a strong IR absorb. And last one of disadvantage is complex mixture simple give rise to complex spectra. For the discussion of FTIR is spectroscopy is a powerful technique for identifying material. It works by measuring the infrared light, a simple absorb, which creates a unique fingerprint based on the sample molecule structure. Different molecules vibrate at specific frequencies when exposed to infrared radiation, and this vibration corresponds to the absorption of creating infrared wavelengths. By analyzing the infrared absorption spectrum, scientists can gain valuable information about the chemical composition of sample. An FTIR experiment involves shining an infrared beam through a sample and measure the resulting absorption pattern. This pattern, called an interferogram, is the mathematically converted into a spectrum that displays peak corresponding to the specific vibration of the molecule in the sample. By analyzing the peak, scientists can identify the functional group present and determine the identity of the unknown material. That's all for me. Thank you.
For conclusion, FTIR spectroscopy effectively identify and characterize the molecular structure of tissue samples by analyzing their infrared absorption spectra. Second, the technique provided clear molecular fingerprints, enabling the identifications of specific functional groups and molecular bonds. FTIR is non-destructive nature and minimal sample preparation. Requirements highlight its efficiency and practicality. Next, comparison of spectra from tissue, cellophane, and cellulose confirm the presence of expected functional groups and unique spectra features. The experiment demonstrated FTIR's versatility and reliability for both qualitative and quantitative analysis. Overall, FTIR spectroscopy proved to be a valuable tool in various applications, including material science, pharmaceuticals, environmental research, and quality control. Thank you.